welcome to the WLMPi update. This is just a short session, 30 minutes, just to tell you everything about the WLMPi, the latest updates on the software side, as well as on the hardware side. And we're excited because we have two new things to announce today, officially.
Do we have the timer?
So let's get right into it. Just to set the scene, if your boss calls you, they ask, well, you've just bought a new spectrum analyzer, 2.4 and 5 gig capable. You've got your tools. I guess you don't need any other tools. You've got all the tools you need for the job. Obviously, the answer is, what do you mean by all the tools? I need the 6 gigahertz spec, and I need tools to actually look into 60 gigahertz, and it's not a single tool job, really. It's you probably want to own multiple tools, software, hardware, to actually design good Wi-Fi. So what is the WLMPi project, if you have not heard about it before? So WLMPi is a community-driven open source project, which means you can download the code, you can contribute. So if you want to be involved, if you have a feature in your mind which you thought would be a brilliant addition, please reach out to us. Or ideally, write the code,
build it.
Reach out to us, and you're more than welcome to contribute. That's how I started. I thought this would be a nice addition here and there, and then I got a message from Jiri asking, would you like to join our team and actually do it with us? So yeah, definitely, if you have any suggestions or if you can actually code it, that's even better. So it's a Linux-based single-board computer, primarily designed for wireless engineers. It helps us design good Wi-Fi, it helps us troubleshoot, do PCAPs, do spectrum analysis as well with a little USB dongle, and much more than that. It started as an iPerf server or endpoint, but yeah, it can definitely do much more at the moment. Good, so that's the project. This is the actual core team, so these are the people who bring WLMPi to you, plus many other of you. We have Nigel in the room, we have Joel in the room. This is Nick.
And this is Jiri.
Thanks.
Okay, we're on this slide.
So that's the team. These people literally put thousands of hours of their own time, so those Friday evenings where everyone else goes to a bar, we sit down and we code, we test. So that's what we are passionate about. And big thanks to the wives and partners of these guys. Yeah.
So maybe we'll have a quick show of hands. Does anyone here not know about the WLAN-Pi? If you've not heard of it before, put your hand up. Okay.
One hand.
So we're reaching a new audience of one. That's fantastic.
Good. Brilliant. So we can give you 5 examples of what you can do with the WLMPi. Some of the new features, some of these are existing features, but just to give you kind of 5 use cases, what is that I can do with this out of the box? So Wi-Fi scanning for verification, troubleshooting, what is my channel utilization, what is the channel plan, what is the channel reuse, and so on and so on. You can do that with a number of tools. There's a built-in Kismet tool. So if you use your WLMPi with an iPad, this is a web GUI, so you can just connect it to your iPad, go to the web UI.
On this one, like the WLAN-Pi has got a Wi-Fi NIC in it. Depending on which model you have, it's a Wi-Fi 6E NIC, and that can be dropped into monitor mode, and then other applications such as Wi-Fi Explorer Pro on Mac OS or Wi-Fi Scanner on Windows, you can then use that device as a local or remote scanner for yourself. Or there's Kismet, which is built in to the WLAN-Pi image. So if you haven't got one of those tools to hand, you start up the Kismet process, access that via a web GUI, and now you've got a scanner and the hardware all coming off of your WLAN-Pi, which is customizable, but not as pretty by a long stretch as Wi-Fi Explorer Pro.
Thanks, Nick. So that's the scanning exercise. You can do this remotely as well, so you can use Wi-Fi Explorer or Wi-Fi Scanner on Windows, ship your Pi to customer site, ask someone to plug it in. You can VPN over to the Pi using Tailscale, for example, which is a peer-to-peer VPN network, and you can do it remotely. So you can connect to someone's remote site, get the same output you get locally. You can do packet capture again locally or remotely, so you can have it attached directly to your laptop, or this can be In the US, we're in Prague today, and we can do packet capture from the 6 gigahertz AP using the 6 gigahertz radio of the WLMPi. If you want to go deeper and there's something going on at the RF level, you want to double check how is the RF looking. So this is a 2.4 gigahertz example with an interferer.
So let me be clear, the WLAN-Pi does not have a spectrum analyzer built in. We're saying here that if you add a spectrum analyzer of like the DBX or the Osmium WLPi, if you add that, if you plug that into your WLAN-Pi, whether that's local to you or remote, Wi-Fi Explorer Pro has now got the ability to pull that data in as well.
And if you have the WLPi, the beauty is that you can do 6 gigahertz. So this is a 6 gig AP, 6 gigahertz spectrum. And this is actually a remote scan. So this is Jiri's home office. And we are scanning the 6 gig band using the WLPi USB dongle. So that now works with all the new WLMPis, the Pro, as well as the 2 we're going to launch today. Profiling, you might have seen this, so just very quickly, what is the profiler? That's an in-house feature developed by Josh and Nigel. What it does is it creates a fake AP, you connect a client to the fake access point, we capture the association request, and we can tell you what is this device capable of, what amendments does it support, what channels does it support. So if you're troubleshooting, this will tell you, this channel is actually not supported by the client, which might be the reason.
Let's do another show of hands. Who has used Profiler on site in anger? Okay.
20 hands, thanks.
Who's used it in a good mood? Okay.
That's few. Good. It can show you the 6E capability as well, so it will tell you yes or no. It doesn't give you more than that. That might be coming at some point, but it will tell you if the device is 6E capable. Now, one of the other use cases, and that's a new feature, this is a bridge mode built into the image. So this is basically a layer 2 transparent bridge between Ethernet, Wi-Fi, and USB interface. The way I used it was I had a camera which is cloud managed, and I needed to upgrade the code on the camera, connect the camera to the cloud, stage it, and then disconnect it, but I didn't have any connectivity. So what you can do is you can use your iPhone's connectivity. The WLMPi will just bridge the USB iPhone interface to the Ethernet. The iPhone will give the camera an IP address from the HCP plus internet connectivity, and you basically have 5G phone providing 5G through the Pi to whatever is at the other end of the cable.
And I think it's worth pointing out on this one, like this is something that a Raspberry Pi could do, but in transparent, well, it's called bridge mode, but in bridge mode, it's just a bunch of settings that you can drop the WLAN-Pi into, and it's all those settings set up for you. So then you plug your iPhone in, or Android phone, then it goes into USB tethering, and now you've got Ethernet out the other end.
Excellent. Thank you so much, Nick. And finally, new features. So between Phoenix and now, these are the new features we have introduced. So we have just shipped the 311 WLPC Prague image. So those of you who are attending the deep dive, you'll be running this image on your WLMPi M4s, soon to be launched. And you will get a WLMPi M4 in the deep dive, which you can keep, obviously. We support new adapters, so this is just enablement for the new Pi editions, USB Wi-Fi 6E adapter, and M2 little card, which you can insert into the Pi. M2 adapter as well. Spectrum analysis we've just spoken about, so including 6 gigahertz.
6 gigahertz
with
the Osmium.
With one of these dongles. There's a new speed test tool. There's an open source LibreSpeed tool built in now. So if you want to have multiple tools, this is a new tool you can use. It measures the internet speed as well as a Pi to Pi speed. So you can use iPerf or you can use LibreSpeed between two Pis.
I'm going to jump in. I'm going to add one.
Go for it.
Also, I think this has changed since Phoenix, but now the Telegram bot is a little bit more secure. So Jiri mentioned earlier the idea of boxing up your a WLAN Pi, sending it to a customer site. Well, if you've already staged that WLAN Pi with a Telegram bot, you can interact with that WLAN Pi via Telegram. So it reaches the customer site, they plug it into an Ethernet port, it gets internet access, and it pings you on Telegram, says, hello, I'm up. The customer didn't even need to call you to say, hey, now I've plugged it in, what should I do? It's up, and you can start sending it commands and getting output via Telegram.
Exactly.
Don't recommend doing this. Well, do your own research. We've locked it down as much as we can, but it's possibly not worth doing that in security-sensitive environments. So it's out of our control, okay?
Good. The reason is the name of the bot is globally searchable. So if you name the bot with a confidential name in it, that's the only information you could possibly leak.
You can probably find the Nick JV Turner WLMPi bot now on Telegram. But hopefully, if you try talking to it, it won't talk back, okay?
Good. So that's that, and there's a few new features on the front panel menu system, the display and buttons. So you can stage it with the reg domain for the Wi-Fi adapter. You can stage it with the time zone and few other bits. So with that, what we would love to do today is to launch 2 new WLMPis officially. We've been working on this for a long time, and I know some of you are in our chat, so you have seen some of that. But today we're ready to actually make this available. So just a quick recap. Odroid C2 was the first kind of edition. I guess many of you probably own one of these. Neo 2 was there for a long time. Great unit, small form factor, but it stopped being available at some point. So we started looking for platforms we could use. We tested probably a handful.
Yeah, so it's worth saying here that the NanoPi Neo 2 availability forced us to reassess what platform the WLAN Pi was built on top of. And the idea was the Raspberry Pi platform has got a big following. It's open source. Like there's enough energy behind that this hardware shouldn't disappear, and we shouldn't have too much problems with supply chain.
Exactly.
Right.
And some software.
So we went with the Raspberry Pi compute module as our platform because it's possible to build a carrier board for that, and we rolled our own hardware, which was the WLANPi Pro, and we threw everything we could at this board. Everything that we thought of, we could add to the WLANPi, we did so on the WLANPi Pro, and I guess the key feature there was the combination of battery, PoE, OTG, all of the things that we wanted.
2 adapters as well on board.
2
everything built in.
Yeah, and so. And it worked, which was great, but because it's custom hardware and we're not talking extremely high volume, the price was necessarily higher to actually manufacture that board. And then
the price tag on it was probably quite high to some of you if you were looking for a sensor which you can ship to a customer. You probably want to keep your Pro on you and actually use it as a perhaps handheld tool to troubleshoot a wired issue, wireless issue.
And then 2 big things changed since Phoenix. Number 1, we'll talk about that one in the next one, but two things changed. I'll address both of those in the next slide.
Good.
So let's roll on.
So the beauty of the Raspberry Pi platform is that the Pro, as well as the 2 new editions, the WLMPi R4 as well as the M4, they run the same image. So you download the image, flash it on the SD card, and you can use that SD card either with the Pro, the R4, or the M4. Don't swap it between them, but it is the same image across the board, and hardware availability is something that the Raspberry Pi Foundation guarantees until 2027 at least. So we know that we won't be looking for new hardware for the next few years, and we can focus on the wireless features as well as the software.
Okay.
Good. So if you would like to see...
roll.
No,
you're not.
I'll do this.
Oh, okay.
We can show you. Would you like to see the new R4 edition? Anyone in the room? Yeah. Okay. That's a yes. So this is the WLMPi R4. Oh, sorry. Isn't. Nick, over to you. I think we have the R4 there.
So thing 1 that changed since Phoenix, a USB dongle came out that does Wi-Fi 6 and unofficially much of the Wi-Fi 6E spectrum. So hang on, Jiri. So this slide is suggesting...
That's suggesting the community approach to this. So the R4 is based on Raspberry Pi 4. So the bare bones of this R4 edition is Raspberry Pi 4 plus a compatible 6E adapter. So that's what we use.
Thank you. So the very basic WLANPi is a Raspberry Pi 4 plus a Wi-Fi NIC that we can get into monitor mode and also supports the bands that you're interested in. And the one step up, actually, do you want to run through your bullet points?
Can do, yeah. So essentially, you can purchase the individual bits, and you can decide. I don't want the case. I don't want display. I don't want buttons. I just want OTG connectivity, USB connectivity to my laptop, and I want to scan 6E using a bare Raspberry Pi 4 plus a compatible 6E adapter, which is this one, this ComFast we are using.
And this means if you've got a if you've got a Raspberry Pi 4 at home already, or I mean, we've probably sold it by now because it's so valuable. But if you've got a Raspberry Pi 4, you've already got a WLANPi. Download our image from GitHub, and you're off. Okay?
Exactly. So it's 6E capable. Obviously, it runs the same image as we mentioned. So the Pro, the R4, as well as the M4, same image. Same features. So it has many flavors. This is just a few examples how we use the R4 before we actually named it the R4. So you can even use it without the display, without the adapter. If you're just using it with OTG and you're troubleshooting a wired connection, that might be one way of doing it. So that's just the Raspberry Pi 4 with a heatsink case on it. On the right-hand side, there's the Wi-Fi adapter plus the display, and this one is the complete unit. So it has the fascia, which is a 3D printed case for it, display and buttons so that you can use the menu, and you can switch between modes and scan and all that.
And this screen and buttons is a WaveShare board. It's a hat, jumps onto the GPIO pins, and basically sits on there like this, except if you want to wrap it up in a metal case, that heatsink case is also made by WaveShare. So you wrap that up, stick the screen on, and you've got a WLANPi now with screen and buttons.
So that's the build your own, as few components as you wish, or if you want to actually buy a fully assembled R4, that's what is available as well. So fully dressed Raspberry Pi 4 with the display, with the buttons, no assembly needed, including the Wi-Fi adapter.
Just that, and the only thing limiting that is the availability of Raspberry Pi 4s.
Exactly that. So, the next one.
Okay. The other thing that changed since Phoenix was the availability of an off-the-shelf carrier board for a CM4 that did much of the things that we wanted. So, if we introduce now the WLMPi M4, or naming R4 for Raspberry Pi 4, and M4, which could mean many different things, but for now we'll just call it because it's got a CM4 in it, okay? So this one has got an off-the-shelf carrier board. It runs a CM4. It runs the same image as the other two. This one's got a single M.2 slot, so that's where you're going to get your Wi-Fi NIC from. This one has PoE built in. So that's the this is sort of positioned as the leave-behind unit. The one thing that we should call out, this unit doesn't support OTG. So if you want a unit that you can power and access over that single cable, the R4 is the right one for you, because that can be powered and accessed over a single USB-C cable from your laptop or your iPad.
Excellent.
The M4 has PoE already inside the box.
It's got one there if you want to show it. There's multiple options to mount this as well, so you can have magnets built in, or an external magnet, or there's a custom way of designing your own bracket if you want to mount it in a different way. So in a rack, for example, if you need 6E clients, you can use the built-in magnets and just do click, 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 5 cables to the Pis, and you have 5 6E capable clients. I should mention that the magnets are optional, so if you want to use them, you can add them later, if that's what you want to do. Good. So just for comparison, these are the 3 editions. If you want to kind of compare them from the form factor perspective. So the beauty of the Pro and the M4 is that they have everything built in inside the case. There's no external adapter needed. With the R4, though, it needs to use an external adapter because the built-in Raspberry Pi adapter cannot be put in the monitor mode, which means we cannot scan, we cannot sniff traffic. So that's that. From positioning perspective, we feel like the R4 is a great complement to an iPad. If you want to use it using the USB OTG connection with an iPad. The M4 ideal as a leave-behind unit, or if you have many of them, as we do in the class, what you can do is you can simply PoE power them. So if you're attending the boot camp, you will get one of these WLMPi M4s. They're all PoE powered by a single switch. So that's quite nice way of actually saving power sockets,
all right,
powering them that way.
So
Good.
Just in case that visual there wasn't enough, I'd like to show you a little bit more of the M4 case design. Okay, so this is the WLAN-Pi M4. And we'll have a look on this side. So this is our PoE port. We've got the SD card slot and activity power LEDs. And this unit has USB 2, no USB 3 controller. From our experience now with the WLAN-Pi Pro, that is a key factor in reducing heat. And although I've presented that as though it was our choice not to have USB 2, this off-the-shelf carrier board doesn't come with USB 3.
On that note, it has a built-in 6E adapter, M2 form factor. But if you want to do multi-channel capture, what you can do, we can borrow this 6E NIC. You have one adapter built in. You can plug another adapter there, and you have 2 adapters you can use to peek up on 2 different channels.
On the other side, we've got USB Type-C for power only, not OTG. 2 more USB 2 ports, and HDMI. And occasionally, we've actually found that to be quite useful, because now you can drive a display. Something to be aware of with all Raspberry Pis, that load needs to be present at boot. So you can't have your WLAN Pi or a Raspberry Pi running and then whack in an HDMI cable and have it produce content. It needs to be present at boot. Let's talk about these mounting ports. On the sides and on the rear of the case, you're going to see a fair number of screws. They're not actually to keep it all together. All of these screws are here as mounting options. So the only 2 screws that keep this case together are this one, and the same 2 on the other sides. The rest of them are there for potentially whatever you want to mount to them. They're M3 threads, and the idea will be, if we have use cases, we can make things that will attach to the WLAN Pi, or you can attach the WLAN Pi to things. In the center here, we have a 1/4-inch thread. And so this one using the standard 1/4-inch thread for other mounting accessories. This part is 3D printed this time around, but this is a separate component. So if you do shred that thread, you can replace it. And now let's have a quick look inside the WLAN Pi, which we'll do using this. And so I'm going to strip this down for you and just show you what each of these components are called. So this is the WLAN Pi M4. Those are the screws. Let's take them away. This is what's going on inside. By the way, the screws are there. There's actually 8 of those. You see those highlighted? The inner 2 are the ones for mounting accessories. Well, that's the idea anyway. So let's take away that end cap and this end cap. That's called the shroud. This is the vanity plate. So the vanity plate there is to hide the circuitry of the WaveShare display board. This WaveShare board has a 5-way joystick, so up, down, left, right, and center click, which works a lot better if you don't glue it together. There's 3 buttons on the right-hand side of the display. So we'll take those away. We'll now remove that WaveShare display. And this is the support sled. So you can see the GPIO pins just poking out there. What about antennas, I hear you say? Yes, the M.2 slot card that we're using has got two PCB antennas. They're the same ones that we used inside the WLAN-Pi Pro. You can see just here, this is where the aux antenna is stuck. And on the opposite side of this is where the main antenna is stuck. We'll whip those away. Let's take away that GPIO riser as well. Here's the heatsink that sits on top of the CM4. And this unit here is the M.2 Wi-Fi cards. So we'll take those away. If we remove those, and underneath we can see these five units, but the 4 slugs, they are the units that provide the thread for the 4 mounting points on the back of the box. If you take them out, so you take the screws out first, then you can take the plastic slugs out, bar magnets will slot into those, giving you a unit that has permanently switched on magnets, and you can slap it to the wall.
I should say the demo unit has the magnets built in, so if you can spot anything metal, feel free to test it.
And that design came about because originally it was going to have magnets only. But then we added the 1/4-inch thread. In fact, Jiri insisted on us having a 1/4-inch thread. So it was necessary to put this unit in there and make some holes in the bottom of the unit. So be it, we'll have options. So that's what the 1/4-inch assembly looks like. And like I say, if that unit gets damaged, we can replace it. And now I've actually now flipped the board around and I'll just build it back up again. So 1/4-inch assembly, plastic slugs, which could be magnets, mounting screws. This is the MCU zone board onto which we stick the M.2 adapter. We're using the MediaTek ones in this unit. This is the CM4, heatsink, GPIO riser. This is the support sled. There's our V-plane riser for the main antenna. WaveShare UI board, squidgy buttons, vanity plate, shroud, and there are end caps, and then we stick the case back on. Oh, I suppose we put the screws back in as well. So this is the WLAN-Pi M4, and we've got 3 minutes.
We do. Any questions?